welcome to Two Projects. In this video, we are going to explain about the project that is RPEE Heads Benchmark, a dataset and empirical comparison of deep learning algorithms for pedestrian head detection in crowds. So before getting into the execution, first let us understand what is this project about. In crowded places like railway platforms or event entrances, being able to detect each person accurately is very important. It helps in managing the flow of people, ensuring public safety, and also planning things like evacuations or monitoring crowd movements efficiently. Accurate detection also makes everyday situations safer and more convenient for everyone, especially in the areas where large groups gather frequently. However, detecting individuals in dense crowds is not easy. People often block each other from view, heads and faces appear at different sizes, and everyone is constantly moving. On top of that, backgrounds can be cluttered with objects or the other people, and lighting conditions can change depending on the time of the day or the location. These factors makes it challenging for detection systems to reliably identify every person in a crowd. So, deep learning models for detecting deep learning models for detecting people need large and varied data sets to learn effectively. So these models rely on seeing many examples of different crowd situations, lighting conditions, and viewpoints so they can recognize people accurately in real world scenarios. With enough diversity in the training data, the model struggles to understand all the variations that occur in the dense, crowded environments. So the problem with the most existing public data sets is that they are often limited in size or focus on small, sparse crowds. Many also lack precise marking for pedestrian heads, which are essential for accurate detection in dense settings. As a result, the model trained on these data sets can fail to detect everyone in a crowd, making it harder to track individuals or analyze crowd movements reliably. So, to overcome with all such issues, this project it focuses on creating a new data set called RPEE heads to help detect people's head in very crowded places like railway platforms or entrances to big events. Most existing data sets don't fully represent these kind of busy real life scenarios. They often miss the variety in crowd sizes, lighting, weather, or camera angles. So here RPEE heads dataset solves this problem by providing clear, high quality images where every visible head is carefully marked by hand. The dataset includes a mix of indoor and outdoor scenes, different times of a day, and a range of crowd densities. With this data, deep learning models can learn to detect heads more accurately, even in crowded situations where people block each other or appear at different sizes. So, here we are using the RPEE dataset, and then the system trains the several deep learning models. So here, RPEE dataset is trained and evaluated on 8 different state-of-the-art deep learning algorithms that are YOLO V7X, YOLO V8X, YOLO V9E, RTDETR, Faster RCNN, and Cascade RCNN, and RetinaNet 101. So these are the models used. So by using multiple approaches, the system can determine which model works best under challenging conditions. And here, the performance of these models is measured using metrics like precision, recall, and average accuracy. That is mean average precision, precision recall, and the inference speed. So that is how quickly they can make predictions. This ensures that the system can reliably identify people's head even in dense crowds. With its capability, the system can be applied to tasks such as monitoring crowds, analyzing how people move, detecting unusual behavior. Moving on, to further improve the performance of this project, as an extension, original RPEE heads dataset has been merged with the another pedestrian head dataset. This combination adds more variety to the data, which helps the system perform better when detecting heads in different crowd situations. To further improve the performance, advanced versions of the YOLO V5 model, specifically YOLO V5 S6, YOLO V5 X6, are used. These models allow for more accurate and reliable identification of the heads, making the system more robust and also effective in analyzing crowd scenes. And here we have developed a simple web interface by using a Flask framework. So here we have developed a simple web interface using Flash framework, which allows users to upload images and see results of the pedestrian head detection directly. The system also includes user authentication, ensuring secure access while providing an interactive and easy to use platform. This makes it practicable for testing and evaluating the detection models. Moving on to implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented. First, we start by loading all the necessary Python libraries required for data handling, image processing, model training, and evaluation. Then comes data preparation. So here we collect data sets from source like RoboFlow and the custom recordings, organize the collected data in the YOLO format for consistency, combine the original RPEE headset data set with the new data set to increase diversity and improve model robustness. And we will be applying data augmentation techniques like flipping, rotation, scaling, and color adjustments to make the data set more varied. And we split the data into training and validation to prepare the model for training and evaluation. Then comes dataset conversion. So for YOLO models, we use YOLO.yml and .txt annotation files directly, and for two-stage detectors, that is Cascade, RCNN, Faster RCNN, and Fast RCNN, RetinaNet, we convert the YOLO annotations into Coco JSON format, ensuring that class labels are consistent across all the models to avoid errors during training. And here we will be training one stage and two stage deep learning models using their respective data sets and training pipelines. And we will be evaluating all the models by using their metrics, that is mean average precision, and recall. And we will be comparing those results through the graphs, and we will be selecting the best performing model. Coming to the front end part. So here we have created a simple web interface by using Flask where users will be able to give input and upload images. After that, that input will be pre-processed at the backend. It will be fed to the train model, and the train model will be giving us the detections. Then we plot precision recall curves and confusion matrix to analyze model performance, display the sample detection results for qualitative analysis, highlight how the model perform on different object sizes, such as small versus large heads to ensure robustness. So this is how we have implemented the project. Moving on to the algorithms used. These are the one-stage object detection models that are used, and these are the two-stage object detection models. And to implement this project, we need two kinds of requirements, which are hardware and software. So in hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So let's open it. So these are the source code files of this project. Let's understand each of them. How will they be used in this project? So let's understand what are these. In this folder, we have the data sets. So here we have data set in two subfolders, train and valid. Let's open train folder. Here we have images of the people, and here we have annotation files for the heads. Let's open images folder. So here we have different images, and we will be locating heads in these images, that we will be using these images to train the model for locating heads, and that object locations of the head we have in this label folder. Let's get back. So similarly, we have data set in this folder, and here we have merge data set. And here we have static folder in which we have files related to CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases folder. So here we have test cases that we will be using in the front end. And here in this folder, we have the images also. So we will be using those images to train the YOLO mod. And this is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have multiple model files which contain the algorithm information, and they will be loaded into the project code during runtime of the application. And here we have multiple Python files, which are important also. And here we have two Jupyter Notebook files. So here we have two Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And here we have signup.db file. This file is a database file, which is used to store the user information. And here we have the other py files. So this is all about the code folder. Now let's execute it. To execute, copy the path of the code folder from the address bar of the file explorer. So copy it. Now open Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path, click on enter. Here you can observe current directory is changed to the code folders path. So now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while, file is being compiled. So this is the address where application has been hosted. So copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link and I prefer Google Chrome, so I will paste it in that. So paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get registered first. So click on register, that is get started, and fill in all these details to create an account. I have already created, that is I have already registered. So I will directly sign in. Click on sign in here and provide your username and the password. Click on sign in. So we have signed in successfully and redirected to this detection page of the project. So this is the detection page. So if you click on try detection, you will be navigated to this option where you need to upload the files. So let's click on choose file to upload the images for detecting the heads in the crowd. So click on choose file. So open the test cases folder, and here you can see so many images, right? So here from this folder, we can upload any of the image which we want. So let's try uploading different scenario images. So first, let's upload with this scenario. Click on open and now click on detect heads. So this given image will be pre-processed at the backend. It will be fed to the train model and the train model will be giving us the detection. So here you can see from the crowd, so many number of heads have been detected and drawn in a blue color bounding box. So here you can see a blue color bounding box is drawn around the head and labeled it as head with their respective probability scores. So here you can see every head, that is for all the persons, the application is detecting the head. Now let's try using the other image. So click on try again. Click on try detection. Click on choose file. So now let's upload this image. Click on detect heads. And here we have the detection. So here you can see multiple heads have been detected from the crowd. So let's try with some more. Click on choose file. And now let's upload from this bright light image. So here you can see multiple heads have been detected and a blue color bounding box is drawn around the people's head. Here you can see, right? So here you can see a head has been detected, drawing the bounding box around their heads and giving the probability score. So now let's check with some more images. Click on try again. Click on try detection. Choose file. And now let's try with this one where there is low light. And here we have the detection. So here you can see heads have been detected. Let's try with some more. Click on try detection. And now let's upload images from, let's upload this image. So here also you can see multiple heads have been detected in a crowded place. Let's try again. Click on try detection. So scroll down. And now let's try to upload this one. And here also you can see heads have been detected. Let's upload the last image. Click on choose file. And now let us upload this image where you can see there is a heavy crowd. Now click on detect. And here you can see all the people heads are drawn in a blue color bounding box. So from the crowd, you can see application is accurately detecting how many heads are there and it is drawing a bounding box around those heads. Now let's check with the graphs. So under graphs, click on original data set. So click on it. So here we have graphs for the original data set. So here on x-axis, we have all the models that we have trained, and on y-axis, we have precision score. And here we have recall score. And here we have ML models mean average precision score. Now let's check with the graphs of merged data set. So click on it. And here we have the graph. So this is the precision recall curve graph. So here on x-axis, we have all the models that are YOLO model, YOLO V5 S6U, YOLO V5 X6U, YOLO V8, YOLO V9, and on y-axis, we have precision. Similarly, we have recall, and here we have mean average precision. So now click on sign out. So this project, it demonstrates a reliable system for detecting people in crowded areas, helping to improve safety and crowd management in places like railway platforms and event entrances. By combining advanced models with diverse and realistic data, the system can monitor crowds effectively, support quick decision making, and also ensure smoother movement of people in busy environments. So just by uploading images, you will be able to detect the heads in the crowded areas. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.